Today, I'm going to introduce the real-time pest detection by using deep learning algorithm. Deep learning technique is getting popular in agriculture, especially for controlling pests. This project focuses on caterpillar detection by using YOLO V8 algorithm, which is one of the deep learning techniques. The model is trained by using caterpillar images and split into training, validation, and test sets. YOLO V8 model is created and trained to detect the absence of caterpillar, and this model can predict the caterpillar in many ways. The problem statement of this project is, from the traditional way of engaging a plantation, the farmer cannot have real-time data on plant growth. So pest and disease detection in agriculture rely on manual inspection, which is very time-consuming and prone to human error. So manual detection may lead to delays in detecting issues and taking corrective action. My objective to do this project is to develop real-time pest detection system using deep learning models, and I want to develop the hardware system with utilizing camera to complete the proposed system. And I will use to evaluate the real-time pest detection through a small-scale field experiment. So, deep learning is inspired by the structure and functioning of the human brain's neural networks. These artificial neurons allows the model to learn complex patterns and representations from the input data. The connections between the neurons have associated weights that are adjusted during the training process to optimize the model's performance. We will use convolutional neural network as our deep learning algorithm. This network consists of multiple layers, including convolutional layers, point layers, and fully connected layers. Convolutional layers is the process of extracting valuable features from an image and make a feature map. Pooling layer will downsample the feature maps and reducing their spatial dimension and retaining the most important information, while the fully connected layers at the end of the convolutional neural network process will extract the features and make a predictions which learn from previous layers. I will use YOLO version 8 for my pest detection. YOLO version 8 is worked based on convolutional neural networks. When we put an image as our input, and it will divided into a predetermined number of grid cells, every grid cell will detect objects that appear within them, and it will use a single bounding box regression to predict the height, width, center, and the cross probabilities of objects, and it will make a final detection. So I will start with software system by collect caterpillar image from Google, and I will start with RoboFlow, which is used to annotate image by labeling the size of the caterpillar. Over 100 of caterpillar will be labeled and split into 3 datasets, which is training, validation, and test set. Also, the image augmentation will be applied to increase the quantity of the dataset. I will use the dataset to train the YOLO V8 model in Google Cloud, and this YOLO V8 will produce a best result model for me to use in my caterpillar detection. For the hardware system, I plan to use Arduino CNC shell to control the stepper motor, and this will let the external webcam to cover every part of the small-scale field, and the webcam will be connected with the computer to detect the caterpillar in a live streaming mode. Currently, the project has completed the detection of caterpillar using the proposed YOLO V8 algorithm. It will show up a bounding box with a confidence score to detect the absence of the caterpillar. The benefit of this project is to help users can avoid pest attack and protect the plant in real time. By using this system, farmers can reduce the use of pesticide and control the pests in a faster way. Without the use of pesticide, our environment will not be polluted and not harm to our health.